The science of fear extinction.
Your brain never deletes a fear. Seriously, let that sink in for a second. Even after your kid completely gets over some massive phobia, like a terror of dogs or being afraid of the dark, that original fear memory is still physically in their brain. It hasn't been erased, it hasn't been overwritten, it survives. And, for parents and educators, this single biological fact completely changes how we need to approach childhood anxieties.
All right, let's dive into section 1, the deleted fear myth.
We've got to look at the clear distinction here between two deeply misunderstood concepts, habituation and extinction. When a child stops reacting to, say, a mild repeated noise in the background, that's habituation. It's just a passive decline in responding to a harmless stimulus. Basically, the brain just gets bored and stops caring. But overcoming a true conditioned fear? No way, that is not habituation. Kids don't just passively outgrow deep fears. What they actually undergo is extinction. And the research on this, spanning from Milad and Cork to Boaton and colleagues, is crystal clear. Extinction is active, associative inhibitory learning. It is an active, ongoing battle inside the brain where brand new learning has to constantly compete against that perfectly intact surviving fear memory. Moving right along to section 2, extinction is new learning. Because extinction is actually the brain creating a completely new memory from scratch. When a child learns that the neighbor's dog is safe, the brain doesn't just drag the dog equals danger file to the trash bin. Nope. Instead, it creates a brand new dog equals safe now file. In neuroscience terms, they call this a CS no US memory. That just means the conditioned stimulus, or the cue, is no longer followed by the unconditioned stimulus, which is the threat. And this new safe memory works by actively inhibiting or literally putting the brakes on the old fear. It's a competitive arena in the brain. The new safety memory must be strong enough to outcompete the original fear trace. And crucially, as we're going to see, this new memory is highly dependent on context. Let's open up the hood in section 3, inside the fear circuit. So picture a whiteboard map of how your brain manages fear. There are 3 major players you need to know in what's called the prefrontal-amygdala circuit. First up, the amygdala. This is your brain's primal threat detector. It's what triggers the freezing, the racing heart, the sheer panic. Second, we have the ventromedial prefrontal cortex, or the VMPFC. Think of the VMPFC as the brakes. During fear extinction, the VMPFC steps up, activates, and actually sends a signal to tamp down the amygdala. And third, the hippocampus. This is the context gator. It evaluates your physical surroundings and essentially acts as the referee, deciding whether the amygdala or the VMPFC gets to win the match in any given moment. It's amazing to see just how universal this circuitry really is. We are talking about one of the best characterized circuits in all of neuroscience. Now, a lot of the foundational work on erasing versus inhibiting fear was heavily rodent-based, but the structural parallels are exactly the same. In the rodent brain, there's a region called the infralimbic cortex, which drives this extinction recall. And human neuroimaging confirms the exact homologous structure right in our brains, the VMPFC. The exact same mechanism that allows a mouse to realize a tone no longer means a shock is coming is what allows a child to realize that stepping into a classroom no longer means they are in danger. The biological hardware is conserved straight across species. Now let's look a little closer at that referee I mentioned, the hippocampus. This explains a phenomenon that literally drives parents and therapists crazy. You know the drill. You spend weeks helping a child conquer a fear of reading out loud at home, or maybe in a quiet therapist's clinic. They're doing great. But then they go to school and the fear instantly returns. Why? Because of hippocampus gating. The hippocampus constantly evaluates the physical context. It looks around and says, okay, where are we right now? Then it tells the prefrontal cortex which rule to apply. In the clinic, the hippocampus says, okay, we are in the safe room. Apply the it's safe now memory. But back at school, the hippocampus recognizes the original environment where the bad thing happened and says, uh-oh, we are in the danger zone. Apply the original fear memory. The safety memory is just inherently tied to the exact context where it was learned. Which brings us to section 4, why old fears return. Listen, if there is one single thing I want every parent and educator to take away from this explainer, it's this. When a fear returns, it is not a failure. It is biological proof that extinction is just new learning and that the old memory is absolutely still in there. Science has documented 3 primary routes for fear to return. Number 1 is renewal. This is what we just talked about. The fear comes back because the child is in a totally new context, and the safety memory just hasn't generalized yet. Number 2 is reinstatement. This happens after a completely unrelated stressful reminder. Say a child is totally over their fear of the dark, but then a highly stressful event happens at school. Their baseline stress spikes, and suddenly they're terrified of the dark all over again. And number 3 is spontaneous recovery. This literally just happens with the passage of time. The original fear memory is durable. It's like concrete. The new safety memory is, quite frankly, fragile.
Finally, Section 5, exposure therapy done right. Okay, this is where we get defiantly optimistic. Because once you actually know the rules of the game, that you aren't trying to delete a memory, but build a competing one, you can totally hack the system. So I have to ask you, how do we teach the brain to win? How do parents and educators help kids definitively conquer these persistent fears if we know the fear never truly vanishes?
We do it through what researchers call the inhibitory-learning approach. Because that new safe memory is fragile and bound by context, our interventions have to be really robust. First, you've got to make the new learning incredibly strong. This means violating the child's expectation of danger in a major, undeniable way. Second, and this is absolutely vital, you must vary the exposure across different contexts. Don't just practice facing the fear in the living room. Practice it in the backyard, at the park, in the morning, at night. You literally have to train the hippocampus that the "it's safe now" rule applies everywhere, not just in one specific room. And third, you have to repeatedly retrieve that safe memory. Every single time the VMPFC is fired up to hit the brakes on the amygdala, that neural pathway gets thicker, faster, and stronger.
And that leaves us with this final, really empowering thought from Fear Me Not. Brave missions don't wait for fear to fade. They teach the brain a stronger, new lesson that wins. We spend so much time hoping our kids will just wait out their fears, kind of hoping the fears will eventually just delete themselves. But the science of fear extinction tells us that true bravery is an active construction project. It's about doing the hard, repetitive work of building stronger, varied safety memories that can outcompete the old fears when they inevitably try to pop back up. So the question we should be asking isn't how do we make this fear go away? The real question is, what stronger lesson are we going to teach the brain today so that it can win tomorrow?